All right. Good morning again, everybody. Thanks for your patience as I figure out how to present here on Hopin. If you have any questions throughout this presentation, feel free to enter them in the chat. My friend Ashley is here, and she'll make sure that I see those questions, so feel free to ask. Today we're going to be talking about TypeScript and some of the advanced features of the TypeScript type system. Before we do that, I do want to take a minute and thank our amazing sponsors. As you certainly know, this is a crazy time for all of us and a crazy time for Code PaLOusa. So thanks for Amazon and Software Guild and Modus and Andromeda for sticking with the conference and sponsoring, even though it's been a very different and unprecedented year. Yeah, so let's talk a little bit about TypeScript and specifically what a language is, right? Any language is just an ability to express ideas. And when you switch languages or switch contexts, sometimes you have different ways to express the concepts that you want to express. Last fall, my wife and I got to be in Australia, and one of the things that we would giggle about all the time was every time we saw an escalator, there would be a sign that said "way up," and that is true. An escalator is a way up to the next level, or a way up to the ground level if you're in the basement. And there's nothing wrong with this. It's just not what we were used to, and so it amused us, while the locals didn't think anything of it. And in the same way, in software, a lot of times we have concepts that we want to be able to communicate or that we want to be able to implement, and we just have different mechanisms to explain them. If you're moving from JavaScript to TypeScript, there's some of these mismatches between, you could think of it as like the cultural difference between JavaScript and TypeScript, where in JavaScript it's dynamically typed, and in TypeScript it's statically typed. So we need to have a robust type system that can do the translations back and forth. One of the things that I want to start off with is just saying what the prerequisites are for this session. I do want to point out that I am going to skip over the basics of TypeScript. I'm going to assume that you already know how to add types to variables and parameters. I'm going to assume that you know how to create classes and use type definition files and configure the build. We're going to kind of blow past all those introductory topics and get into some of the more advanced parts of the type system. So just a quick review so we're all on the same page about what I mean by a data type. The textbook definition of a data type is a data type defines a collection of data values and a set of predefined operations on those values. I say this is the textbook definition. I literally got it out of a textbook, one that my wife is mad that I still have. She thinks I should throw it away. It's been 20 years. She's probably right. Anyway, I've still got it. I looked it up. So if we're going to whiteboard this out, we would say that we can have a type, and the type is made up of the data that it contains and the operations on that data. Or we could also say that a type has state and it has behavior. So a slightly more concrete example would be that we could have a type, and that type has a couple of fields, it might be a string, might be an int, and that has some functions that it can perform using that data. So like a person class could have a first name that is a string and a last name that is a string, and we could have a function called getGreeting that returns a string. Let's talk real briefly about generics. So with generics, what we have is the ability to define some of the types later. We can defer the definition of the types. So I could say I have a type of T, and then the data type of field data 1 is of T, and the return type of function 2 is of type T, which would be really nice if I have something like an array. So I can now have an array of type T, and I want to fill that array with type T. This is some code that I have from a solution or a little test project I built that solves the 8 queens problem. If you're not familiar, the 8 queens problem is the idea that you should be able to place on a chessboard 8 queens such that none of them can attack each other. Obviously not in a real game, but just in the concept of the queen piece and how it moves and how it can attack. You should be able to place 8 of them on a board, 8 of them on a regulation chessboard. To solve this, I need to have an array of type queen. And the standard JavaScript array class is loosely typed, and so you could have anything that goes into your array. In TypeScript, we can say that the array specifically is going to be an array of queen objects. That way, when we assign new items into that array, the compiler can make sure that we're only assigning the correct type. And when we access items out of the array, we can be sure that they're the correct type. And this is legitimately the method from the GitHub repo for that project. One of the things I want to point out about the TypeScript type system is that when it gets loaded in the browser, it's not TypeScript, right? It gets transpiled to JavaScript. And so this is that same function once it's running in the browser. In fact, I probably used the Chrome debug tools to grab the screenshot. And one of the things that you can see here is that in the third line where it says this.queens equals new array of this.board size, my generic is gone. Right? Once I'm in the JavaScript, all the type safety I've created is out the window. And this is not simply true of generics. This is true of all the things that we're going to look at in this presentation. When we talk about intersection types or union types, those are things that we know in our TypeScript code, but at runtime, those things are gone. The TypeScript type system helps us to write code. It gives us better tooling while we are in the IDE. Once you're in the browser, you're back to totally dynamic code. All right, let's talk a little bit about basic inheritance. If we had a data type before, we could have like a parent data type. In this case, the parent has function 1 and function 2. We could have a child type that overrides function 1. It adds function 4. We also add data 3. But the child type has all the behavior and state of the parent type. Now, if you're used to the class hierarchy in JavaScript, you know that JavaScript has prototypal inheritance, meaning that it gets its behavior and state from its prototype, which can change. TypeScript has traditional object-oriented inheritance structures. So the behavior and state that are acquired are from the parent type, not from the prototype. And if we talk about inheritance, we can say that inheritance produces an is-a relationship. So the child type is a instance of the parent type. So if we have a programmer that inherits from person, we could say that a programmer is a person. And in this case, the person has first name and last name. The programmer has favorite language. But the programmer then also has a first name and a last name because it is an instance of a person as well. So if I here look at the type definition of person, you can see it defines a constructor and a get greeting. And then the programmer extends person. So if you're used to a C# syntax for inheritance, this is a little different. Instead of the colon, we now have the extends keyword. And instead of the type name being the name of the constructor, we actually have the constructor keyword. But we can see that we can also override, and we don't have to use the overrides keyword. We can just say public get greeting, and when we define that in programmer, it overrides the behavior in person. In general, where we are in the state of software development is that we believe that composition is greater than inheritance. When we think about inheritance, we're creating these is-a relationships, and as those get more sophisticated, they're almost always not communicating exactly what we want to build. A lot of times developers will misuse inheritance to share code when really what they ought to do is they ought to compose those classes together. When we use inheritance to share code, a lot of times we're violating that is-a relationship. This is sometimes formally known as the Liskov substitution principle, which was originally coined by Barbara Liskov. And she pointed out that when we violate those is-a relationships, we're really on the road to bugs in a hurry. All right, let's get into some of the more interesting types in TypeScript. And the first one we want to look at are intersection types. In the examples we've looked at thus far, we had this idea that we could have a class called programmer that might have a field for a favorite language and a function called getGreeting. And we could also define a class called billable resource that would allow us to get the invoice for that resource. Well, what if we wanted to have a class that had the behavior and state both of programmer and of billable resource? We don't necessarily want to have programmer inherit from billable resources because we can't always say that a programmer is a billable resource. And certainly we don't want to have billable resource inherit from programmer because, again, the is-a relationship doesn't work. What TypeScript allows us to do is have intersection types where we can say, I want to create a new type that has the behavior and state of both programmer and billable resource. So in this example, we can see that I can create a new interface called programmer employee, and I can have an interface for billable resource. And then down here in the second line of the test function, I can say let billable programmer equal programmer employee and billable resource. When I've done that, I can now create this type that you can see we can assign a first name and a last name and a favorite language, all of which come from the state of the programmer employee. And we can also assign an hourly rate, which we're getting from billable resource. And then we can assert on those fields. We also have the ability, you can see the functionality here, where we have the get greeting and the get invoice amount. What I would need to do is have a custom function called extend, where I actually will then very intentionally and very explicitly copy all the functions from one to the other. But you can see that the return type of extend is of type first and second. And I'm using generics here. So my extend function is going to say it's going to take the generic parameter for first and the generic parameter for second. And it's basically going to return the intersection type of the two types that are passed in. And what I'll do is create a new type and then add all of the properties from first and all of the properties from second, and then return the result. So once I've done that, now I can create, you can see here on line 4, new programmer, and I could call get greeting because it's a programmer. I could on line 9 create a new billable resource, and on line 10 I could expect the invoice amount to be 80. So there's the behavior from billable resource. What I can then do on line 14 is I can create a new type named Don that is the intersection type of programmer and billable resource. And you can see on line 15, I can call the method from programmer. On line 16, I can call the function from get invoice amount. So intersection types allow me to take two types and combine them together without creating an inheritance hierarchy. All right, are there any other questions before we go on about intersection types? All right. The next type I want to talk about, or I should say, I guess, next type of types I want to talk about is the union types. These are not types that have gone on strike to advocate for better wages and better working conditions. They are, in fact, the types that can be one or another type. So let's say that we have types for programmer, and the state of programmer is, again, favorite language, and the behavior is get name and get favorite language. And we also have a type for tester. And the tester also has a get name string. We can see here that we've defined classes like I just showed you for programmer and tester. And we also then created a class for product owner. So in this example, we're going to be simulating some Scrum ceremonies. So let's say we have a class called sprint task, and we have a method called assign, and we want to be able to assign a person to that task. And the assignment could either be a programmer or a tester, but we would not want it to be the product owner. So what I can do is I can, for the argument to the assign method, I can have a union type of programmer or tester. And so what I can then do is I can pass in an object. The compiler will verify that I either passed in a programmer or a tester. They do not need to have a common base class. It just needs to be one or the other. You can see here on line 6 that I can call the get name function on the person object, which was passed in. And that's because the compiler knows that both programmer and tester have that get name method. So that's going to be a valid result no matter what. If I try to call the get favorite language, that wouldn't compile because tester doesn't have a get favorite language function. So the compiler knows that that might not be a valid option. So in this case, what I could do is I could, again, create on line 16 a new programmer, on line 17 a new tester, and on line 18 I'm creating a new task. On line 20, I could assign the programmer. On line 23, I could assign the tester, and both of those would pass. Now, if I tried to do the same thing with a product owner, like I am on lines 28 to 32, you can see that I can create the product owner, I can create the sprint task, but if I try and pass the product owner to the assign method, it won't work. And let's actually jump over and look at the code for this, which is right here. So I'll just uncomment that line of code for a second. Let me make my font a little bit bigger. Here we go. So now if we look at this error, we can see that the IntelliSense is saying that argument of type product owner is not assignable to the parameter of type programmer or tester. It actually further goes on to say that type product owner is missing the following properties: get name. Because TypeScript has implied types, if product owner happened to have all of the same behavior and state of tester, it could be converted to a tester. But in this case, that's not what we want. We're just glad that we can't assign a product owner to a sprint task. That is the behavior we want. If we come up here, we can actually see in the assign method that it's taking the union of programmer or tester. So it's telling us which one of those we need to have. Now, one of the things that I want to point out is that union types are probably most commonly used to safely represent potential error cases. And what I mean by that is a lot of times we have functions that are going to retrieve some data or create some data but have the possibility for an error. So let's imagine for a second that we have a class in our TypeScript code that is going to look up some programmer information in the database and return that information. And in this case, I've got a programmer repository, which is obviously not looking up anything in the database. You can see on line 20 that it's simply returning an error. But just imagine for a second that the programmer repository class here I wrote has some more interesting behavior. As you know, when you look something up in a database, there are 1 or 2 or a million ways that that could go wrong. So typically what we would do would be that we would either have the return type be an error code and then actually return the program or the data we would want as an out parameter. That's maybe like the older C style way of handling it. Or we could return the programmer, and if there's an error, we'll throw an exception. That's certainly fine, and code can work that way without a problem. The trick with that is that there's nothing in C# or TypeScript that forces you to catch the exceptions. So you always have that possibility of an unhandled exception. With union types, what we can do is we want to say that the return type is going to be the union type of programmer or lookup failed. You can see here on line 16, I am defining a new type that is just the union type of programmer or lookup failed. And so what I can do is on line 19, when I have my method called getByName, it's going to return this programmer lookup result. You can see on line 20, right now I have this hard-coded to return a lookup failed. If you use your imagination for a second, you can imagine some code in here that would also connect to a database, pull the fields out, populate a programmer object, and then potentially return that programmer as well. Now, the great thing about this is that it forces my code into a pit of success. So if we see here on line 19, I've instantiated a new programmer repository. On line 22, I am going to do a getByName, and it's going to return a result. And let's jump back over to the code so we can see this a little more dynamically. So I can say getByName, and it's going to return a result. The IntelliSense is telling us that the result is of type programmer lookup result. Now, I've got this result object, and I know that it is either a programmer or a lookup error. And if I say let language equal result dot get favorite language, you can see I'm getting a compiler error. And the compiler error specifically is telling me that the property get favorite language does not exist on type programmer lookup result. Further, it knows that because the property get favorite language does not exist on the type lookup failed. So a lot of times what I want to do is I want to then figure out what the type is and handle it appropriately. So you can see here on line 9, I'm saying if result instance of programmer, then let language equal result.get favorite language. It's worth noting that this line of code here on line 10 is identical to the line of code on line 8 that wouldn't compile. The TypeScript compiler is smart enough to know that once I've had a guard clause in an if statement on line 9, that the type of result must be a programmer. So it'll allow me to do it here. The nice thing about this style of handling errors is that I don't have the option to have unhandled exceptions. If I want to do anything at all meaningful with the result, I need to check the type and then manipulate it. Probably what I would also have in this code is I could say else if result instance of lookup failed. And then here I would want to do, maybe I just want to log the failure kind or the failure reason. But because I have to at least acknowledge there might be an error to be able to get to the fields of either get the programmer or the lookup failed, my code is now going to force me into this path of properly handling all the results. This is a very common way to handle errors in functional languages. In languages like F# or Clojure, we would refer to this error handling style as discriminated unions. You can actually see the class names I'm using here are discriminated unions. And it's just a way to represent that a type is one of several types. In my examples, I'm just unioning together 2 types. I could clearly union together more than that. All right, one more example this morning of sophisticated type in the TypeScript type system is string literals. So one of the things I can do in TypeScript is I can define a type that kind of looks like a union type, but a union type of hard-coded strings. So in this case, I can say that the type of grade is one of the strings A, B, C, D, or F. And then what I could do is define a function called enterGrade that is going to take the student name as a string and the grade as a grade. And let's look at this guy. So if I say enter grade Eric Potter B, that compiles just fine. And B here is a string. It's not anything special. It's just a hard-coded string. If, for example, I tried to pass an E to enter grade, you can see that I'm getting a good error here that tells me that argument of type E is not assignable to parameter of type grade. And yeah, the grade here is A, B, C, D, and F. Now, one of the things you might ask is, how is this different than an enumeration? And you can see here on lines 9 to 11, I could also define an enum for the grades. One of the things that is true about enums, and you can see it here in the IntelliSense, is that the underlying storage mechanism is an integer. So in this case, A is 0, B is 1, C is 2. With string literals, I can define a type where the underlying storage mechanism is a C, or excuse me, is a string, which is very convenient in some cases. I could also have literals for numbers like dice roll. So I could say a dice roll is 1 or 2 or 3 or 4 or 5 or 6. But these literals are just not as different from enums as you might hope. You could also have literals for floating point numbers, which I get if you could have it for integers, you could actually have it for floating point numbers, because like JavaScript, TypeScript only has one number type, and it is floating point, the IEEE 754 floating point standard. In my experience, the number literals are not as useful as the string literals. One of the reasons for this is that TypeScript is so commonly used in the browser, which involves a lot of DOM manipulation, which means you're working with strings quite a bit. So you could imagine a situation where you have a function that should only work with p tags and divs, but not a tags. Right, so you could define string literals for the things that you want to be able to build up there. All right, I'm going to stop again, take a sip of coffee. If there are any questions about string literals, now would be the time. It's really just a cheap way for me to get to drink some of my coffee. All right.
Tyler has a quick question.
Tyler, what's your question? Okay, so Tyler asked, I'm only familiar with TypeScript in Angular. Can you use TypeScript outside of that? Yes, absolutely. So the base TypeScript compiler is an NPM package. And so you can take any TypeScript file and run it through the TypeScript compiler and generate the JavaScript from that. Typically what people do is they will integrate the TypeScript compiler into their build pipeline for their application. So I'm guessing, and maybe this is not accurate, but I'm guessing the way that you started using TypeScript is you created a new Angular project and it integrated the TypeScript compiler into your Webpack or Gulp or Grunt or whatever build tool you're using, and it's doing that for you. There are similar tools for React, for example. If you use the Create React CLI, you can choose to build your React app with TypeScript. There are tools that allow you to create Node.js applications with TypeScript. I think there's a project called Node.ts. I'm not sure if that's the real popular one anymore. I know that Cypress now supports TypeScript. So there are a lot of these different JavaScript frameworks that have TypeScript options built into their tooling. And if not, again, you can always just download a standalone TypeScript compiler. It's called TSC, and transpile whatever you want. Yeah, here Edward is saying that his team uses TypeScript with React and Redux. That is certainly a thing that can be done. And one of the great things is that we're starting to see more and more tools support TypeScript out of the box, so you don't have to go in and manually configure it. Yeah, Dan uses it with Vue. That's cool. That's not one I had heard of, but it's good to know that that's there too. I'd be curious if there's anyone here that's looked at using TypeScript with Svelte. That's another combination I've not heard of anyone using yet, but I bet it's coming. I'm going to take another sip of coffee. Does anyone else have any other questions before we go on? Yeah, Edward points out that like a lot of things, when you're not using the primary language, some of the documentation requires a little bit of manual conversion. So most of the documentation you see for React is in JavaScript, and so you have to manually convert that to TypeScript. Yeah, I don't know. I haven't looked to see what Pluralsight has recently. Edward is saying that Pluralsight is of little help. The big Pluralsight author on React is Corey House. I could not think more highly of Corey House. He is a brilliant presenter, a brilliant teacher. He does prefer JavaScript to TypeScript, although he is softening on that opinion a little bit recently. But yeah, it'd be great if he would do a course with React and TypeScript. Hit him up on Twitter. Make that suggestion. In fact, I'll troll him on Twitter this afternoon and tell him he should do that because you said so, Edward. Good question, guys. Keep them coming. Love the interaction here. Johnny says, I primarily use ASP.NET MVC and want to use TypeScript, but I have trouble finding training. Really want to use TypeScript, though. Know of any resources? That's an interesting question because the Microsoft tooling is generally pretty good about getting TypeScript set up in your ASP.NET MVC core apps. I assume what you're talking about is the actual documentation. That I don't know. I haven't looked at the docs.microsoft.com page, which is where Microsoft puts a lot of their best documentation. I know I've looked at some books from A-Press that did TypeScript with ASP.NET MVC. Yeah, maybe I'll have to look that up. I don't know anything off the top of my head about resources for TypeScript and MVC. Maybe hit me up either on the Slack for Code PaLOusa a little bit later, and I'll see what I can find. Yeah, I don't want to spend a lot of time here just speculating about it. Oh, okay. Yeah, maybe Johnny, maybe you and I should have a conversation about this. I have actually done a couple projects where we converted from JavaScript to TypeScript very slowly and very smoothly. One of the great things about TypeScript is that it is a superset of JavaScript. And so all you have to do to convert a JavaScript file to a TypeScript file is change the extension from JS to TS. And then there are ways to kind of start slowly integrating that. That is not something I'm going to cover in this session. I don't have any slides on it or anything. So again, maybe you and I can just have a conversation in Slack later. All right, let's jump back over. Yeah, Edward says use Webpack. Yeah, Webpack and Grunt and Gulp are all tools that are work really well to do your entire JavaScript build pipeline, including the TypeScript transpilation. All right, so let's wrap up where we're at with using the advanced features of the TypeScript type system. One of the things I want to clearly express here is that the TypeScript type system has a lot of sophisticated features, and it's not your job to use them all. The stuff I showed today, I think, is very useful. It is not something I use all the time. In fact, the things, intersection types and union types are things that I maybe use fairly infrequently. But when you need to know them, they're incredibly useful. That's why I highlighted that example of using union types to return errors. Because when you return a union type as an error, you can clearly express to readers of that code in the future, which include your teammates or future teammates or the future version of you, exactly what that function is going to return. That's where we want to use the TypeScript type system, is to clearly express the intent of the software, not to do some stunt coding or crazy code tricks, but to clearly communicate what we want the software to be. All right, if you want to see the code that I was showing today, that is all available up on my GitHub, github.com/PotterEric, TypeScript Beyond the Basics. The slides for this presentation are up on SlideShare, although like within the last week, SlideShare got bought, so I don't know, maybe that's going to go away anytime, sometime soon. But for right now, they're still up there. Also, we're at Code PaLOusa, and there is a Slack channel. If you want to jump in the Slack channel, feel free to message me. You can probably find me as Eric Potter, or my username might be eric.b.potter@gmail.com. If you want to find me later, the easiest way to find me online is at Twitter. I am @PotterEric. You'll notice the theme. I can never quite get my name on the internet. Freaking Harry Potter fans squatting all the good Potter names all over the internet. So I am most commonly PotterEric because it's easier to find. You can also see some of my further thoughts on TypeScript on my blog at humbletoolsmith.com. Thanks for coming out this morning. Hope you learned something. Hope you picked up some information that is going to help you be able to deliver better software solutions for your customers. That being said, you've been a great audience, and I will see you around. Enjoy the rest of your conference.